Good morning students. Let's start with a new topic by finding out the area of a trapezium. So what is a trapezium? A trapezium is a quadrilateral whose two sides are parallel, and if its non-parallel sides are equal, then it is said to be an isosceles triangle. Okay, so a trapezium is a quadrilateral, means four sides are there joined together and two of the sides are parallel to each other. These two sides are parallel to each other. Now if there are any non-parallel sides, if there will be non-parallel sides, are these two are the non-parallel sides, and if both the sides are equal, means the side length is equal, then they will join up to be at particular point where they will form an triangle, and that triangle will be known as an isosceles triangle. As you know, isosceles triangle means where two sides are equal. So this is particularly a trapezium where A is one of the side and B is the base, and this is the height, that is perpendicular distance from top to the base. Now how we will find out the area of a trapezium? So two methods are there to find out the area of a trapezium. First method is by splitting the figure. How? If particular figure is given to us, how we will split that particular trapezium figure into two figures and find out the area. Here, by splitting the figure, you can see here that this is a trapezium, right? Because its parallel sides are opposite sides are parallel. These two sides are parallel, so that will be considered as a trapezium. How we can split this figure into? I have already shown here. Here this ADCB is completely a trapezium which is divided into two figures, that is ADEB as one rectangle and another is DEC as another triangle. Okay, so there are two figures here, a triangle and a rectangle, and both the figures you know what is the area of a rectangle and area of a triangle. Okay, so these two areas we are knowing already. So when we add both the areas, then we get the area of this whole trapezium. So that is by splitting the figure. This is one of the formula to find out the area of trapezium, that is by one of the method, that is by splitting the figure. So in trapezium ABCD, it can be divided into two parts, that is a rectangle here, that is, and a triangle. So area of ABCD will be equal to area of ABED plus area of DEC. And you know what is the area of a rectangle? That is length into breadth. This is length and this is breadth. And what will be the area of the triangle? Half base into height. So if we are knowing all these measurements, then it is easily we can find out by finding both the areas and then adding both the areas to find out the area of this trapezium. This is one of the method, that is by splitting the figure we can find out the area of trapezium. And next is directly by the formula. What is the formula? Area of a trapezium is half multiplied by addition of both the parallel sides. A plus B. A is one of the parallel side and the other is B multiplied by height. Here, like you can see here, this is A and this is B. So formula, according to formula, half into A plus B multiplied by this height. So this is the direct formula of how to find out the area of a trapezium. Let's find out. Calculate by an example. Calculate area using both the methods. We will calculate the area. Here a figure is given of a trapezium where ABCD, in which AFED is one of the rectangle that we have divided. By first we will do find out the area of trapezium by splitting the figure. So this I have split into two figures, that is, this is rectangle and two triangles. So area of trapezium ABCD will be equal to area of triangle ABF, this is one triangle, plus area of rectangle AFED, then again addition of this second triangle, that is area of triangle DEC. So we have split the figure into three figures, that is two triangle and one rectangle, and then it is we can easily find out the area of this trapezium. Let's find out by putting all the values into the formula. So first we know that what is BF is equal to EC. So BF is equal to EC. Both the length are same. So if we know AD is 6, so what will be BE here? BE will also be 6 here. So here see 16. This is this whole BC is 16. 16 is equal to BF plus FE plus EC. BF plus FE plus EC. And these two things are equal. So 16 is equal to 2 multiplied by 2 times BF. Why? BF and EC are equal here. So you can write in place of EC, you can write BF. So there are 2 times of BF, so 2 BF plus AD. Why AD? Because FE is equal to AD, and we know the measurement of AD, that is equal to 6 centimeter. So 16 is equal to 2 multiplied by BF plus 6. So therefore this 6 will come here. 16 minus 6 is equal to 2 multiplied by BF. Therefore 10 is equal to 2 BF. So BF will be equal to 5 centimeter. So now we know the measurement of this, that is the base of the triangle. And what is the formula of the area of triangle? That is half base into height. So base is also known now and height is also known. So area of this triangle we can easily find out, and the measurement of this triangle is exactly same. So value of both the area of both the triangles will be same. So what is the area of a trapezium? We have divided into two triangles, so area of that triangle is 1/2 base into height plus middle portion is the rectangle, so length multiplied by breadth, plus again one more triangle is there, so half B1 multiplied by H1, that will be second breadth and height. Now here half base into height. So base is BF, and BF we have found here as 5, and what is height? 5. So same goes here, this is 5 and this is 5. So we will multiply half base into height, that is 5 multiply 5. And then what is the area of rectangle? 6 multiplied by 5. Length into breadth. Length is 6 and breadth is 5. So here half multiplied by 5 multiplied by 5 plus length into breadth, that is 6 multiplied by 5 plus again same measurement for the second triangle. So 25, 5 is a 25 by 2 plus 30 plus 5 multiplied by 5 is 25 by 2 again. So if we add both the 25 by 2 plus 25 by 2, that is 50 by 2 plus here this 30. 50 by 2 means 25. 25 plus 30 is equal to 55 centimeters square, because we are finding out the area of the trapezium. So by splitting the figure, we have got the area of trapezium as 55 centimeters square. So what is our next step is, second we will find out directly with the formula. And according to the formula, area of trapezium is half sum of the opposite parallel sides, that is A plus B multiplied by height. Half A plus B. A is the top, that is 6 plus base will be 16 multiplied by what was the height? 5 centimeter. So half multiplied by 6 plus 16 is 22 multiplied by 5. So 2 11s are 22. 11 5s are 55 centimeters square. So by using both the method, we are getting the same answer. So area of trapezium can be find out by two methods, that is one by splitting the figure, or by second by directly by the formula, that is half sum of opposite sides multiplied by height. So let's now find out a new topic, that is area of general quadrilateral. So there will be any quadrilateral, how we can find out the area of that particular quadrilateral. A general quadrilateral can be split into two triangles. Like we have done for trapezium, how we have find out by splitting the figure into rectangle and two triangles in the earlier example. Same way, a quadrilateral can be divided into two triangles by drawing one of its diagonals. Like if we are drawing a diagonal in between a figure of a quadrilateral, then we are getting two triangles. Based on that, we can split the quadrilateral and then find out the area of that general quadrilateral. This triangulation helps us to find a formula for any general quadrilateral. So here this is a quadrilateral A, B, C, D. If I am drawing a diagonal AC, then I can divide this particular figure into two triangles, and now by finding out the area of these two triangles, it is easily, and adding both the areas, we can get the area of this particular quadrilateral. So let's find out how we are doing it. Area of quadrilateral ABCD will be equal to area of triangle ABC plus area of triangle ADC, where here H1 I have drawn as the perpendicular height to the base. This will be the base of the triangle, that is H1 is the height of triangle ABC, and here H2 will be the height of the triangle ADC. So area of triangle ABC plus area of triangle ADC, that will be equal to half multiplied by AC. AC is the base. What is the formula of area of triangle? Half base into height. So what is base here? Base will be AC and height will be, for this triangle it will be H1. And for this triangle, half into base, again base will be same, that is AC, and height will be H2, that is multiplied by H2. Now see that what is common in both, that is half multiplied by AC is common. We will take it out, half AC, and what is remaining inside, that is H1 plus H2, that is the two height. So our general formula for finding out the area of general quadrilateral will be half multiplied by AC, H1 plus H2, where AC is the diagonal. Okay, this is the diagonal that we have drawn. So half, this is diagonal D, multiplied by H1 plus H2, where D denotes length of the diagonal AC. So let's see an example where we have to find out the area of a quadrilateral that is given to us, that is PQRS, and measurements are given, that is here two triangles is already drawn, and this is the diagonal, that is QS is the diagonal, and here H1 is 2.5 and H2 is 1.5 centimeter, and the length of the diagonal is 5.5 centimeter. Now according to the formula, half D, that is the diagonal, multiplied by H1 plus H2. All the datas are given here. We just have to put this value into this formula and find out the area of this quadrilateral. So area will be equal to half multiplied by D, that is the diagonal, multiplied by H1, that height 1, H1 is the height 1 of the first triangle, plus H2 is the height 2 of the second triangle. So half multiplied by what is the length of the diagonal that is given, that is 5.5 centimeter. And H1 is given to us, that is height 1 is given to us 2.5 and H2 is given to us 1.5. So if we add both the heights, then we are getting 4. So 1 by 2 multiplied by 5.5 multiplied by 4. 2 2's are 4. Then 5.5 multiplied by 2 will be 11 centimeter square. So like this we can put the values into this formula for any general quadrilateral to find out the area of any general quadrilateral. Area of special quadrilaters. So which are special quadrilaters? How to find the area of such quadrilateral? Here one of the special quadrilateral that is given to us is rhombus. So what is a rhombus? Where all the sides are equal and their diagonals are also equal, of same length. So area of a rhombus, how we will find out? So this you can see that again by triangulation or by dividing that particular quadrilateral into triangle, we can find out the area of this special quadrilateral rhombus. So area of triangle ACD plus area of triangle ADC. So which are the two diagonals that are drawn here which are equal length, that is AC and BD. both are the two diagonals and those are of equal length. So if they both are meeting at a point O, so area of triangle ADC, what is the formula? Half base into height. What will be the base here? Base will be AC. And what will be the height here? OD or DO. So half AC multiplied by OD. Then plus, what will be the area of ABC? Half base. Here again AC will be the base, multiply by OB. Now half AC is common, so I will take it out. Then OD plus OB will remain inside. Now it is clear that OD plus OB is nothing but BD, right? So I have written here AC multiplied by BD. And here you can see that AC is one diagonal and BD is the next diagonal. So I can write it as half multiplied by D1, that is diagonal 1, multiplied by diagonal 2, where D1 is equal to AC and D2 is equal to BD. So area of a special quadrilateral can be found out, special quadrilateral, that is rhombus, can be found out by this formula, that is half into multiplication of the two diagonals. Now, how to find the area of a polygon? What is a polygon? Polygon is n number of sides when connected together to form a closed figure or a closed circle. Here, polygon that is given to us is a pentagon because it is having 5 sides, 1, 2, 3, 4 and 5. So if we want to find out the area of a pentagon, as we have done in trapezium or rhombus, we will first divide that particular figure into triangles, or splitting the figure you can see. So by constructing two diagonals from where A to C is one diagonal and then AD. Two diagonals if I am drawing, I am able to divide this particular polygon or pentagon into three triangles, right? This is 1, 2 and 3. Now by finding out the area of each triangle and by addition of all these areas, we can get the area of this particular pentagon, or yes. So this is by splitting the figure for to find out the area of any polygon. So we can do by first constructing two diagonals AC and AD. The pentagon ABCDE is divided into three parts, 1, 2 and 3. So area of ABCDE will be equal to area of this triangle, that is triangle ABC, plus triangle ACD plus triangle ADE. So area of the triangles will be half into AC, that is the area base of first triangle, that is AC, multiplied by height. Height is H1 here. I have taken H1 for height of the first triangle. Then plus half AD, second triangle. What is the base for second triangle? This is the base, so AD multiplied by what is the height? H2. So multiply by H2 plus third half into base. Base is AD again here, multiplied by H3. So when we we can see that half AD is common in these two triangles. So we will take that out. Half AC multiplied by H1 will remain as it is, plus half AD multiplied by H2 plus H3. So this is kind of a formula we are creating for any polygon that is given to us, area of any polygon. So this way, whenever any polygon of any number of n number of sides will be given to us, we have to divide this into such triangles by drawing the diagonals, and then finding out the area of each triangle, we can get the area of that particular polygon. So it is by splitting the method. No direct method is there for area of a to find out the area of a polygon. We have to split the figure into different n number of triangles, and adding all the area of that triangle, we can find out the area of any polygon. Now, how to find the area of a polygon? What is a polygon? Polygon is n number of sides when connected together to form a closed figure or a closed circle. Here, polygon that is given to us is a pentagon because it is having 5 sides, 1, 2, 3, 4 and 5. So if we want to find out the area of a pentagon, as we have done in trapezium or rhombus, we will first divide that particular figure into triangles, or splitting the figure you can see. So by constructing two diagonals from where A to C is one diagonal and then AD. Two diagonals if I am drawing, I am able to divide this particular polygon or pentagon into three triangles, right? This is 1, 2 and 3. Now by finding out the area of each triangle and by addition of all these areas, we can get the area of this particular pentagon, or yes. So this is by splitting the figure for to find out the area of any polygon. So we can do by first constructing two diagonals AC and AD. The pentagon ABCDE is divided into three parts, 1, 2 and 3. So area of ABCDE will be equal to area of this triangle, that is triangle ABC plus triangle ACD plus triangle ADE. So area of the triangles will be half into AC, that is the area base of first triangle, that is AC, multiplied by height. Height is h1 here. I have taken h1 for height of the first triangle. Then plus half AD, second triangle. What is the base for second triangle? This is the base, so AD multiplied by what is the height? h2. So multiply by h2 plus third. Half into base is AD again here, multiply by h3. So when we we can see that half AD is common in these two triangles, so we will take that out. Half AC multiplied by h1 will remain as it is, plus half AD multiplied by h2 plus h3. So this is kind of a formula we are creating for any polygon that is given to us, area of any polygon. So this way, whenever any polygon of any number of n number of sides will be given to us, we have to divide this into such triangles by drawing the diagonals, and then finding out the area of each triangle, we can get the area of that particular polygon. So it is by splitting the method. No direct method is there for area of to find out the area of a polygon. We have to split the figure into different n number of triangles, and adding all the area of that triangle, we can find out the area of any polygon.